ModEx is a general-purpose system for the exploration of computer models. ModEx is developed within the Viz-R visual analytics framework. A common analysis in genome biology is to detect genes that are expressed differentially under different biological conditions. Here we import a data table of gene expressions acquired using RNA sequencing technology. We can browse through the data table using the Viz-R's built-in table view app. In addition to the real genes, it also contains 92 synthetic genes with known expression, called spike-in genes. The column labeled GT_DE shows the ground truth differential expression state for the spike-in genes. Spike-in genes that are known to be differentially expressed between two biological conditions are labeled true, and those that are not differentially expressed are labeled false. All other genes with unknown state are labeled NA. To perform differential expression analysis, here we use an app that uses a popular bioinformatics method called DE-seq. We first add the app to the workspace and drag and drop the data table. We then specify the data columns corresponding to each biological condition. DE-seq takes several other parameters, but we will leave them to the default values for the time being. Click the Run button. Viz-R will then run the DE-seq method with the specified data and parameters. Once done, it outputs a scatter plot called an MA plot, as well as a histogram of the detected differential expression states. These labels, as well as other computed statistics, are added as new columns to our data table. Once again, we can use the Table View app to browse through the data. We can use the filters to see the false negatives and false positives in the output of DE-seq. This brings us to the question of how should the detected DE state of other genes be interpreted? In other words, we want to know whether the statistical test that DE-seq performed based on our input parameters was a sensitive test or a specific test. Similar to the standard analysis, we need to add the DE-seq app to our workspace and assign the input data. This time, we click on the ModEx toolbar button to switch the app's parameter view to the ModEx mode. In this mode, rather than single values for each parameter, we can specify ranges of values. ModEx will use the specified ranges to create random combinations to run the app with. After specifying parameter ranges, we specify an output directory to store the output of the app for each parameter combination. Finally, we specify the number of times we want the app to run. Here we specified 500 runs to show the stability of the tool, which took about 3 days to complete. Once the sampling process is finished or stopped by the user, the derived output view of the ModEx app is opened. First, we select the directory we had specified earlier as the run's output directory. We can then run the derived output feature to compute summaries of our runs. We provide a wide range of derivation methods described in more details in the paper. Here, we compare the isDE output of each run with the ground truth DE column of our input table. This will go through all 500 runs and count the number of matches and mismatches between the ground truth and the computed DE states. We will now look at the exploration interface of ModEx. The runs info table in the data view contains the information about each run, including the parameters and the derived outputs. The runs overview shows the runs info table where each data point is one of the runs of the computer model. A common method to analyze sensitivity or specificity of a computer model is to use a ROC plot. We set the x-axis to show false positive rate, which is the number of genes with a ground truth DE of false but detected state of true. We also set the y-axis to show true positive rate, which is the number of genes correctly detected to be DE equal to true. The parameters as well as the derived output are shown on the runs distribution view. Clicking on each parameter changes the runs point color to that parameter. We notice that almost all optimum runs on the Pareto set of the ROC plot use the blind value for the method parameter, so we use the filters to only select those runs. Clicking on a data point for a run shows the plot generated by the computer model after executing that run. Multiple runs can also be selected. Here we compare runs on the far ends of the Pareto set with a mid-range one. Looking at the sharing mode parameter, we see that most Pareto set runs are using a value of fit only or maximum, so we filter those. Finally, we see that the FDR threshold parameter is highly correlated with the placement of runs along the Pareto front. Selecting the FDR threshold around 0.4 seems to provide a reasonable trade-off between a high true positive rate and a low false positive rate. As we interact with the runs, the run output table is also updated with the output of the selected run. This allows us to extend and enhance the default workflow by linking other apps as needed. Here we use an interactive scatter plot and set it up to show the gene activations colored by the detected DE state. So as we select different runs, the interactive scatter plot will also refresh accordingly. This concludes our short walkthrough of the ModEx framework. For more details, please refer to our paper. Thank you.